Welcome everyone, Math 105. This is lesson 2 on scientific notation and evaluating variable expressions. So variable expressions are used in all sorts of fields, such as business and science, to calculate important values. And we're going to see some examples of doing that today. And we're going to start off with scientific notation, because this is something that is used quite often to express very large or very small numbers. So scientific notation has a format where we take a number that's between 1 and 10, and then we're going to multiply it by a power of 10. So you're always going to see this kind of a format, and we'll have an exponent here on the 10. So we're going to figure out what that exponent is going to be. So to convert from standard scientific notation, start where the decimal point lives, just to the right of the number. And then we're going to count over the number of spaces until we create a number that's between 1 and 10. So that's going to be the number 5.17. If we move the decimal there, that gives us a number between 1 and 10. So let's see how many spaces that is. 1, 2, 3, 4, 5. We're moving 5 to the left. So that is the number on the exponent. 5.17 times 10 to the 5th. And the x actually does mean multiplication. So you could take 5.17, multiply it by 10 to the 5th, and get 517,000. And what you all need to be able to do is to work with these numbers in a calculator. So make sure that you can enter these into your calculator and then also perform computations with them. Your turn. We're going to write both of these in scientific notation. Keep in mind, if you have a very small number like this, the exponent will be negative. Just a reminder, I don't pause the video for your turn, so pause it on your own and then resume when you're done. First one, okay, it's negative, so the number will be negative. That stays, the sign stays. Now we're going to count over. 1, 2, 3, 4 places gets us to 5.39. And that's between 1 and 10, so that's what we want to do. So we're going to do 5.39 times 10 to the, and we move 4 spaces. And since we're dealing with a very small number, that means the exponent is negative. Negative 5.39 times 10 to the negative 4. Now this negative and this negative have nothing to do with each other. If I didn't have a negative here, I'd just remove that one. This would still be negative. B. All right, let's see how many places we have to move the decimal this time. All right, starting to the right of the number, we got 3, 6, 9, and one more gives us 10. So 10 brings us between the 4 and the 0, so we get 4.0489. Include all the non-zero digits. And we moved it, how many spaces did we move it? We moved it 10 spaces. So 4.0489 times 10 to the 10th power. We can also do this in reverse. So example 2, I'm going from scientific notation to standard notation. Alright, so the exponent tells us how many places to move the decimal, and the negative says that we're going to make this number smaller. So we're going to move it to the left. 4 spots. So 1 gets us here, and then we'll need 3 more, so we're going to need 3 zeros in front of the 3. So it's going to be 0, 0, 0, 3, 4, 8. And decimal point goes there, and usually a leading 0 goes out front, because a decimal point can be hard to see if you don't have that leading 0. Your turn, number 2. So with this one, we're going to move the decimal 5 places, and since it's a positive number, we're moving to the right to make this number bigger. So it's going to be 1, 2, 3, 4, 5. The decimal goes between the 2 zeros. So that gives us 207,480. And then our decimal point, and then 0.3. Part B. 7.138 times 10 to the negative 3rd power. So we're going to move it 3 places. Since it's negative, we're moving it to the left to make the number smaller. So 1 gets us to the left of the 7, then we'll need 2 more zeros. So 0, 0, 7, 1, 3, 8. And decimal point goes to the left. All right, now we're going to get some more order of operations practice. We're going to do very similar activity to last time, except this time we have variables and we're going to be given the values of the variables and we're going to plug them into the formula. This is something that happens quite often in science and business and many other fields where we use these type of expressions. All right, so for every instance of the variable, plug in 2. So 5 times 2 to the third, 2 to the third is 8. Now we're using order of operations, exponent first. And 40 for that one. Your turn, number 3. Now we're plugging negative 3. Recall that the exponent only applies to the thing in parentheses, but applies to everything in the parentheses, the negative too. So negative times negative is positive, so this will be positive. 4 times 9, or 36. Now, some expressions have more than one variable, and we'll see an example of that next. For x plus 5y when x is 8 and y is 9. Just got to make sure we plug the right number in the right spot. So 8 for x, 9 for y. Now we'll multiply it out. We got 2 multiplications separated by addition, so we can do them both at the same time. 32 and 45, add them together, and we get 77. Your turn, number 4. So we have negative 3x plus 4y when x is 4. So plug that in here. And y is negative 2. That gives us negative 12 plus negative 8, negative 20. We get AB divided by negative 2b when A is negative 6 and B is 4. Now when I plug in negative values, I always put them in parentheses. It's a good idea to do that. When you do this, it becomes impossible to mix that up and interpret it as a negative sign or a subtracting symbol instead. Eliminates confusion. So you got negative 6 times 4 there, and then negative 2 times 4 on the other side. All right, so order of operations, we're going to do inside the parentheses first. And negative 2 times 4 is negative 8. So here, if I didn't put that in parentheses, I'd have 4 divided by minus 8, which makes no sense. So make sure you put things like that in parentheses. Okay, now we're down to multiplication and division, so we're going to work left to right. Start here. Negative 6 times 4 is negative 24. Negative 24 divided by negative 8. Negative divided by negative is a positive, so that is positive 3. Your turn, number 5. All right, we've got negative 6d divided by 3c in parentheses. So plug it in negative 5 for d in parentheses, and then 3 times 2. So we'll do the parentheses first. 3 times 2 is 6. And then multiplication and division, work left to right. Negative 6 times negative 5 is positive 30. So that gives us 30 divided by 6, which is 5. Our next one, we've got a fraction here, 3cd over 4. Plus 2ab. And now we've got 4 different variables. So here it becomes really important to take it at a moderate pace, make sure you get the right values in the right spot. Easy to make a mistake on these. All right, c is negative 2, so we got negative 2 in there for c, and d is 4. And a is 1, so 2 times 1, and b is 5. 2 times 1 times 5 on the end. Now, we could start with order of operations here, but notice we have a cancellation we can make. 4 on top, 4 on the bottom. So let's cancel each other out. Remember, that only works if these are multiplied together. If we were adding or subtracting here, it wouldn't work. So now all we have here is 3 times negative 2, which is negative 6. And then over here, 2 times 1 times 5 is 10. Add them together, and we get 4. Your turn, number 6. So we got c, negative 6. We'll plug that in here. Make sure to put the entire value in parentheses, because we're squaring the entire value of c. So whatever c is should go in parentheses. Well, if it's negative. Now we got 3 times a, 8 for a, and b on the bottom is a 2. So that gives us negative 6 squared, that's 36. 3 times 8, 24. 24 over 2, that's 12. So 36 minus 12, and we get 24. So these expressions are starting to become a little more complex. Make sure you're real careful about where you're plugging stuff in and follow order of operations. C minus d squared minus 5ab, where a is negative 2, b is 3, c is negative 4, and d is 1. All right, plugging in negative 4 for c, 1 for d, that's negative 4 minus 1. Square that, minus 5 times a is negative 2, and b is 3. Oh, no, that. Okay, there we go. Now let's do the parentheses first. Negative 4 minus 1 is negative 5. Keep it in parentheses, squared. And we're separated by subtraction, so we can go ahead and multiply these out. Got 5 times negative 2 is negative 10, times 3 is negative 30. All right, now we can square this, get 25, minus negative 30. Subtracting negatives like adding a positive, so that's 25 plus 30, or 55. Your turn, number 7. Okay, for this one, A is 2, B is 8, C is negative 5, and D is negative 1. So for B, got 8, C, plug in a negative 5, keep those in parentheses, 4 times 2, let's see, A is 2, D is negative 1. All right, so we're all plugged in. Now we're going to go over here to the parentheses. 8 plus negative 5 is 3, so that gives us 3 squared minus, and then over here, 4 times 2 times negative 1 is negative 8. That gives us 9 plus 8, or 17. All right, now we're going to dig into some larger fractions. Keep in mind, with big fractions, we're going to evaluate the numerator and the denominator separately using order of operations. And then once we're down to a single number on top and a single number on the bottom, then we'll divide. Example 8. All right, plug it in. C is 2, so we got 4 times 2 up top, and D is negative 8, so we're subtracting negative 8 in parentheses. And on the bottom, we got a negative times A is 1, and B is negative 4. Order of operations on top. We're going to start with a multiplication here. And then subtracting that negative is like adding, so we have 8 plus 8 on top. And then negative 1 times negative 4 is positive 4. So that's 16 on top over 4. And the answer is 4. Your turn, number 8. So plugging in on top, again, A is 5. So that's going to equal negative 4 times 5 on top. And the bottom, B plus C, so 6 plus negative 4. All right, negative 20 on top, 2 on the bottom, so that is negative 10. Now for example 9, got a little more complex fraction here. Now we got a negative out front of the fraction. It's very easy to lose that negative. We got to make sure on each step we keep it there. All right, up top, C is 6, Keep that negative out front. And D is -4, so you can put the -4 in parentheses and square it. And then the bottom, -4 times B, which is 3, plus 7 times A, which is 2. All right, keeping that negative out front. I've got 18 here, and we've got an exponent here. We're separated by subtraction, so we can do those at the same time. So we're going to do 18 minus 16. And on the bottom, here we got -12 plus 14. So finishing off the numerator and the denominator, that gives us 2 on top and 2 on the bottom, or -1. Your turn, number 9. So we're plugging in 6 for B, 2 times 6 up top, and D is -2, so 3 times -2 in parentheses. And on the bottom, C squared, C is -3, so put that in parentheses, and square it, minus A, which is 7. All right, order of operations on top, we got a multiplication here and here, separated by subtraction. We can do both of those. So that's 12 minus -6. And on the bottom, we're squaring -3, that gives us +9, minus 7. Up top, 12 minus -6 is 12 plus 6, so that's 18 on top, 2 on the bottom. Down to a single number on top and bottom, we can divide to get 9. Number 10. Got some fractions here. Often these will be designed so you can get a nice cancellation. And we got A is -3, B is 6. Plug it in -3 for A, 6 for B. All right, so let's go ahead and do the exponents. So we got -2/3 times 9 minus 1/9 times 36. Right here, we got 9 divided by 3 is 3, times 2 is 6. So -6 there. Here we got 36 divided by 9 is 4. -6 minus 4 is -10. Your turn, number 10. Going to plug in -2 for A. Make sure to put in parentheses. And 1/3 times 9 squared. There for B. All right, so exponents, -2 squared is 4. So we got -1/4 times 4 plus 1/3 times 81. Here it gives us a -1. And 81 divided by 3 is 27. -1 plus 27, that is 26. Example 11. Now we have a 3 for A, so plug that in there. 1/7. Now B times C, that's 6 times 4. Minus E times D, 3 times 1. All right, we'll do the parentheses first. Well, we're separated by subtraction, so I can go ahead and simplify over here. The 3's cancel, giving us -2 here. Now we'll do 1/7 times 24 minus 3. Finishing off the parentheses, that gives us 21. 21 divided by 7 is 3, so that's -2 minus 3, or -5. Return 11. Plugging in 4 for A. And then we've got A times C, so 4 times 7. Minus B times D, so 2 times -1. Alright, got a cancellation here, 4 over 4. So that's 1 plus 3/5 times 4 times 7 is 28 minus -2. 28 minus -2 is 28 plus 2, so that is 30 here. Now we'll do 30 divided by 5 is 6, times 3 is 18. Add it to 1 and 19 is our answer. All right, now we're going to look at some applications. So our first one is the food stand. Owner of a food stand sells fresh baked pretzels for $2.50 and drinks for $1.25. The owner created a formula for calculating the total revenue today. It is R equals 2.5P plus 1.25D. R is the revenue, P is the number of pretzels sold, and D is the number of drinks sold. So I'm going to write down the formula. And this is how a lot of formulas work. We set it up beforehand, and then once we know the values, we plug them in, and very quickly are able to calculate the quantity we're looking for. All right, so we got $2.50 per pretzel and $1.25 per drink. Plugging in the numbers, 78 pretzels were sold. So 2.5 times 78. And 123 drinks were sold. 1.25 times 123. And multiplying this out, order of operations, we can do the 2 multiplications. That gives us 195 revenue for the pretzels and 153, 75 for the drinks. Adding them all together, that gives us 348, 75. When you answer word problems, make sure there's 3 parts to your answer. The number, the units, dollars, and then a little description of what we're talking about. Total revenue is 348, 75. All right, next up, we're going to exercise our scientific notation skills. So we're calculating the force of gravity between a couple of asteroids. So with a problem like this, we have to read through and make sure we can pick out the values and get them into the right spot. So we've got the gravitational constant, the masses of the two objects, and the radius, which is the distance between them. Now we're given the gravitational constant. It's the last thing, 6.67 times 10 to the negative 11. And the two masses, 1.95 times 10 to the 6. And 2.36 times 10 to the 6. And finally, the distance between is 47,285, and we're going to square that value. All right, multiplying across on top, make sure you can do a calculation like this in your calculator. Multiplying those, and we get 4.602 times 10 to the 12th over, and then if we square the bottom number, that's 2.24 times 10 to the 9th. All right, now we can either multiply across on top or divide, it doesn't matter. So I'm just going to go ahead and divide here. We divide those out, we get 2054.46, and finally multiply by 6.67 times 10 to the negative 11th, and we get 1.37 times 10 to the negative 7th, and the units are newtons. So the force between the asteroids is 1.37 times 10 to the negative 7th newtons. All right, next up is the chemistry lab, and this is designed to be a group activity with 3 people, where the 3 team members go off and calculate some value that is needed in the final equation. It's okay, you can do this on your own though, just do each part, and once you get the 3 values, then you can plug them into the ideal gas equation. So first up, team member 1 is calculating the pressure. And for this one, we have this equation, lots of funny looking symbols. We got variables with subscripts. May not have seen these before, maybe you have. All right, so we have 1, 2, 3, 4, 5 different quantities we have to find, 5 variables. So we're going to read through the description and get the right quantities into these variables. Now, when you have, oh, this must be a variable like this, sometimes we may have 2 different temperatures for 2 different things, and we still want to use T for temperature. But to differentiate between the 2, we'll put a letter down here called a subscript, and these end up being 2 different variables that way. So it's a way you can use the same main letter in more than one place. All right, now P is the pressure in atmospheres. Tm and Tb are the melting and boiling points of Krypton in degrees Kelvin. All right, so 2 different temperatures, melting point, boiling point. W sub A is the atomic weight of krypton, N is the atomic number of krypton, and B is the gas pressure constant, which is given in the problem. So I can plug that one in right away. The gas pressure constant is 1.73 atmospheres over degrees Kelvin. Right, we don't have to worry about the units right now. And now what we're going to have to do is go up into the description and get all these values. So let's find the melting point and boiling point of krypton. All right, so there's a paragraph here describing krypton, all about it, atomic weight, atomic number. Looks like there's a melting point of 115.75. And a boiling point of 119.95. All right, W sub A, the atomic weight of krypton. So in that same paragraph, we have atomic weight, 83.798. And then the atomic number is 36. And there's all of our values. Calculate that out, and we get a pressure of 1.7 atmospheres. All right, part 2, pump up the volume. And the equation here, 2/3 pi r cubed plus pi r sub t squared h. All right, so we're calculating the volume of the tank. So we've got the half sphere portion on top and the cylinder part of the tank right here. Put them together, we get the whole volume. So basically, what we're talking about here, we've got a rounded top and a cylinder part. So here's the cylinder part of the tank. And then on top, kind of a rounded top on there. So we've got a radius there and a radius there. Okay, RT is the radius of the tank, so this would be RT here. Radius of the tank, radius of the top. All right, so we've a paragraph here talking about the tank. It's 36 centimeters tall, so there's the height. All right, so we got 36 for H. Has a radius of 5 centimeters, and the radius of the rounded top is 3 centimeters. So that's 3 squared here, pi, pi times 5 to the third. And I believe I put those in the wrong place. I think I switched those two. Okay. We have, all right, this is the rounded top. Rounded top is 3, so I have 3 here and 5 there. There we go. Gets a little confusing when you have that. Same variable, different subscript, but we're working out. Okay, so now we're ready to calculate it out. So we've got 2/3 times pi times 3 to the third is 27. Plus, and over here we got 5 squared is 25 and 36. Oops. Okay, 27 divided by 3 is 9. You can go ahead and do that. And then times 2 is 18. So that's 18 pi plus, 25 times 36, that is 900. And I'm just going to leave it in terms of pi. So the volume is 918 pi. And then if you want to, you can go ahead and multiply this out. And that gives us 27.4 cubic centimeters. All right, cubic centimeter is the same as a milliliter. And we haven't done metric yet, but we moved the decimal 3 places. If we want in liters, the volume is 2.28274 liters. All right, part 3, temperature rising. All right, got a bunch of weird symbols here. You don't have to know what any of these mean or what they are. You just need to be able to find the values and put them in the formula. All right, TL is the temperature inside the tank in degrees Kelvin. All right, so if we look at the description then, let's see, actually let's start with the rho first. This is the Greek letter rho, and that is the density of the tank material. So if we look out at the description, we find a density of 7.81, and that temperature was 299.7 in Kelvin. All right, now C then. C is the specific heat of the tank material, and that is found in the description there. Specific heat is 0.248. And then we'll divide by W, the thickness of the walls in centimeters. So from the description, we got 0.42 centimeters. And then our last symbol, phi, heat transfer constant given in the description, 1.25. Right, so the challenge there is just wading through all that and try and find the right values. All right, calculate this out, and we get 274.2 degrees Kelvin. Now we have all 3 values that we need. And we are now ready to use the ideal gas equation, which will tell us the number of moles of particles of Krypton. All right, so we got our pressure, 1.7 atmospheres, that goes in for P. We have our volume, 2.8274. And R is given, the ideal gas constant, given up top, which equals 0.08. And finally, we need T, which is found here, 274.2. And we calculate that out, and we get 0.216 moles of Krypton gas. And a mole is just a number of particles. So working in teams often happens just like this, where each team or each team member possibly goes off, finds some result, brings it back to the group. Each group member does that, and then the group does something with all the results and creates something else. And that wraps up for today.